Hey everyone, welcome back to another edition of College Algebra the Musical. Well, then again. Anyway, so this is section 1.6. Other types of equations, like many of the sections, we're going to break this up into two videos. This first video, there's a lot of things in section 1.6. There's all these different types of equations. We're not going to do all of them. In this video, we are going to hit solving polynomial equations by factoring. So other than quadratics, there are other types of polynomials that can be factored. And so we can solve those equations by factoring. And we're also going to do things that are in quadratic form. They're not quadratics, but they act like quadratics. And so that's the plan. A polynomial equation, as you might expect, if you're going to factor it, you want to set it equal to 0 and then try to factor things out, and then you use the zero product property, which applies to multiple products. Even if it's more than two things multiplied together, if there's 3 or 4 things multiplied together, you can still break them all up into individual pieces and set them each equal to 0. So here's an example. Solve this by factoring. 2x cubed plus 3x squared equals 8x plus 12. If we're going to factor, right, then we've got to move everything and set it equal to 0. So we subtract 8x from both sides. We subtract 12 from both sides. All right. And then we factor by grouping because there's 4 items. So if we take these two people here and these two people here and group those guys together, there's an x squared in common between 2x cubed and 3x squared. So there's an x squared in common here. We factored out. Negative 8x minus 12, there's a 4 in common, but there's a negative in common also, and we always want to take the sign of the first term when we're factoring by grouping, so we factor out the negative 4, and we're left with a 2x plus 3 again. So we're left with 2x plus 3 and 2x plus 3, and so that pulls out here, and then we factor that out, and it's leaving us with x squared minus 4. Okay, so this is a factored form of this polynomial. However, because we're not just doing quadratics, we're doing other types of polynomials with higher degrees, we might have to factor again. And in this case, we do have to factor again. The 2x plus 3 is just fine. But x squared minus 4, right, that is a difference of squares. X plus 2, x minus 2. And so we set those equal to 0, and we break them up. We get 2x plus 3 equals 0. We get x plus 2 equals 0. We get x minus 2 equals 0. And so if we solve each of these, here we get 2x equals minus 3, so x equals negative 3 halves. Here we subtract 2 from both sides to get x equals negative 2. Here we add 2 to both sides to get x equals positive 2. So we have 3 answers. X cubed, we should expect 3 answers. We have 3 answers, negative 3 halves, negative 2, and positive 2 as our solutions to this original equation, 2x cubed plus 3x squared equals 8x plus 12. Okay, so factoring process is the exact same as it was for quadratic equations. It's just a little bit more complicated, or you might have to do more than one factoring, and that's what we had to do here. We had to do factor by grouping, and then we had to do difference of squares. Okay, so simple enough. You can check your answers back here, test them, make sure that they work. All right. So I'm going to try something different starting with this video. I'm going to give you what I call you try it's. And so here's a second example. Okay, so we're going to solve this one by factoring. 2x cubed plus 5x squared equals 12x. Okay. And I want you guys to try that one. And then pause the video right now. Try it based on the one you just did. And then come back and I'll work it with you. Okay? So hit the pause and try this one. All right, so how do we solve this? Well, it's the same as last time. We're going to try it by factoring, which means the first step is to set it equal to 0. So we need to subtract 12x from both sides, set this equal to 0. Notice there's an x in common everywhere. So we get 2x squared plus 5x minus 12 equals 0. And if you spend a little bit of time, if you do the AC method, AC is 2 times 12, which is 24. If we break that down, there's lots of things that multiply together to give you 24, but 8 and 3 multiply to give you 24 and subtract to give you 2x or 8x. And so we get 2x squared plus 8x minus 3x minus 12. We got to do this all inside the parentheses. And so this becomes 2x squared plus 8x minus 3x squared plus 12. We pulled out the negative, so it makes everything positive inside. Okay, and so then we factor out the 2x. We have x plus 4. We factor out the 3. We have x plus 4. And so we have x times x plus 4 times 2x minus 3 equals 0. So if you'll break these up, this will tell me x equals 0. This will tell me x equals negative 4. And this will tell me x equals positive 3/2 if I do the algebra. Okay? So once again, we get 3 answers. And it works out great. Okay? So that's how you do those. The other type of problem we're going to look at is problems that are in equations that are in quadratic form. So they act like quadratics. You can factor them, or you could even use the quadratic formula in the correct way. We're not going to look at any of those right now, but that's possible, right? Because they are quadratic. And so what does it mean to be in quadratic form? What that means is that it acts like a quadratic. In other words, how does a quadratic look? A quadratic looks like ax squared plus bx plus c equal to 0. And so what does quadratic form look like? That means it looks like au squared plus bu plus c, but u may be a function of x. Okay? So it's anything where the power here is twice as much as the power here, and then there's a constant. Okay, let me show you what I mean by that. Take a look at this problem. X to the 4th minus 5x squared plus 6 equals 0. Now, it's not a quadratic, but x squared is x to the 4th. And so this is x squared squared. This is x squared, twice as much in the power as this one. And so let u equal x squared. Right? We're looking for something that's in this form, au squared plus bu plus c. And so if we let u be x squared, then we get u squared, right? This is u, minus 5u plus 6. Okay, and then how would you solve this? How you would solve this is you factor it. U minus 6, or excuse me, u minus 3. It's a plus there, u minus 3, u minus 2. This tells you that u minus 3 equals 0. This tells you that u minus 2 equals 0. So u equals 3 and u equals 2, which is great, except here's the thing, it's not about you, right? You may have been told that before. It's not about you in this case. It's about x. What was u? U was equal to x squared. And so we plug in x squared for what the u was, x squared. And now we solve for x, and in this case we solve by extracting roots. So we take the square root of both sides, getting plus or minus the square root of 3. Here we get plus or minus the square root of 2. How many answers do we have? 4. What's the power? 4. That's not surprising either. Okay? And so obviously that makes sense. And that's the process. So notice we solved this equation just like we did back in section 1.5 by factoring simple quadratic, all right? But once again, all right, that wasn't the final answer. We had to do a substitution to get this to look like a quadratic, and then we treated it like one, and then we went back to x's. Okay, so that's the process for quadratic form. If you can see this, some people can see that this factors into x squared minus 3 and x squared minus 2, and if you can see that, that's awesome. And you are welcome to just jump on and do that and then head on down to here and do the last couple of steps. But most students can't see that, and so the u substituting process is very highly recommended. Okay, so like last time, here's a second example, but you're going to try it this time. I'm going to give you a couple of hints though. One hint is that 1 over x squared is the same thing as 1 over x all squared. And 3 over x is the same as 3 times 1 over x. So I'm kind of giving you a hint here as to what your u might be in order to make this work. All right, so again, pause the video at this point. You've got the previous example written down, hopefully. And if not, you can go back a little bit, but pause the video at this point and try this problem. And I'll be back with you in a minute. Okay, so it's pretty obvious we're going to let u equal 1 over x. I hope that went well. And so that means u squared is 1 over x all squared, which is 1 over x squared. So this equation becomes u squared minus 3u minus 4. That's easily factored into u minus 4, u minus 1, or plus 1, which tells me that u equals 4 and u equals negative 1. But again, it's not about u. What was u? U was 1 over x. And so this means 1 over x equals 4 and 1 over x equals negative 1. If you kind of cross multiply here, think of this as 4 over 1 and cross multiply and solve, you'll end up with x equals 1 over 4. Here you end up with x equals negative 1. So again, there's a little bit more work to do. 2 answers. Okay, this is not a polynomial even, right? This is not a polynomial because the x's are in the bottom. But the process still works because it's in quadratic form. All right, so that's the end of the first half of section 1.6. I hope that helps. And stay tuned for part 2.